A very good evening, dear viewers. I extend a very warm and hearty welcome to everyone this evening. Myself, Joya Khan, your host for this evening, from GETI as Ambassador of Change. I extend greetings on behalf of the Global Education and Training Institute, a name to reckon with, where excellence is a continuous process and not an accident, where the things you do for yourself are gone, but the things that you do for others remain your legacy. It's an immense honor to share that Getty is founded and conceptualized by our revered mentor, Dr. Sunita Gandhi, a pioneer with a broad vision of disruptive education. Ma'am's perseverance and persistent efforts has placed Getty on a high pedestal as one of the most premium training institutes of India. Under it, we provide two types of trainings: one pre service for the aspiring teachers who wish to be outstanding teachers in future, and the other in service, where we train teachers who are already in service so that they themselves can spearhead this disruptive movement of the literacy campaign, which is spreading its wings far and wide, making its presence felt as a people's movement. On this forum, we also conduct live talks under the banner Detox, where we invite bureaucrats, policymakers, entrepreneurs, and esteemed speakers from all around the globe as agents of positive change to enlighten us with varied educational practices carried out all over the world. Under the magnificent vision of Dr. Gandhi, we are continuously striving to bring about transformative changes in education. This evening, dear viewers, I feel extremely privileged and elated to have with us on board Dr. Kumar Gautam, founder and CEO, Quantum Research and Center of Excellence, all the way from New Delhi. He has very graciously consented to enlighten us by sharing his views and experience on the topic quantum computing, and it will change the education system. We welcome you, sir, on this live forum. And just to throw a little light upon his career, Dr. Gautam is founder and president of Quantum Research and Center of Excellence, as well as founder of a Green Quanta LLP. He is a strong educational professional with a Doctor of Philosophy, PhD, focused on quantum gate design from Delhi University, with MTech from NIIT Rourkela and BTech from IIT Delhi. He has 8 years of teaching experience and has worked as an associate professor with a demonstrated history of working in the higher education industry with skills in MATLAB, quantum computation, Python, and so on. Dr. Gautam has several prestigious awards and achievements to his credit. He is a senior member of IEE with effect from 15th August 2020 till now. He is also a lifetime member of Deccan Environment Research Organization. He also has to his credit the Best Entrepreneur Award, Deccan Environment Research Organization Awards 2020, Best NGO in India, GNE Award of Excellence 2021, Global NGO Expo. He has also got the award of Innovative Quantum Research Organization of the year 2021, World Startup Conclave 2021. He has also been awarded with Research Collaboration 2021 with QUTCWA, Australian startup in quantum dot technology. President of Technology and Product Solutions at Alumni Association Network from 2021 August till date. His primary target would be to generate employment in quantum computing for skilled and unskilled workers who understand or wish to understand the technology or can be trained to use the system optimally according to the uncertain conditions. So, with his very relevant topic in the present scenario, I once again extend a very warm and hearty welcome to Dr. Gautam, and over to you, sir, for the entire show.
Okay. Thank you so much, ma'am. Thank you to GETI to giving us such a great opportunity to interact with the such emerging technology. Thanks to Dr. Sunita Gandhi also, the creating a institution and for the everyone. And she is a very highly motivated and towards the society and everything. And thanks to Joya ma'am also to beautiful speech and beautiful interaction and descriptions about my simple what I did. And thank you so much.
Thank you.
Okay, shall I start?
Yes, sir, please go ahead.
Yeah. Okay. Um, Hello, audience. As I ma'am already described everything about that. What I'm a founder of Quantum Research and Center of Excellence, and I did my PhD in quantum computing. So this is a very close to my heart, the quantum word exactly. So right now here we are not any discussion about the such mathematical terms. We are not so much describing about what exactly the system are basically trying to use. Here we are actually describing basics, what exactly the aim of the QRACE and why the quantum computing is more connected with the education. What exactly the change? What is the pillars of the quantum computing and what is the pillar to change the education system? So this is the basic goal of what exactly we are planning to do. The goal is like everyone, even government of India and other organizations like IITs, ISSR, and many other institutions are basically doing so many things like a quantum gate design, ion trap based, or quantum in communication. In DRDO is more prone to focus on the communication sections and with the collaboration of IIT Delhi. And some of the institutions are basically working on the some quantum dots technology, designing the quantum antennas. So simple, basic. What is the quantum? What the QRACE is a non-profitable organization and working with as a independently to develop the effective relationship with process partners in the research community of scientists, researcher, as well as the non-research community also for the development of the quantum computers. So where QRACE is major concern about the designing the quantum computers, and QRACE is more prone to work with ion trap and rare atom. So it has become imperative both the government industry to the partners to develop these emerging and disruptive technology in order to secure our communication, fintech, remain competitive and derive the societal progress, generate employment, and also focus on how to grow the economy and support the government systems to improve the overall quality of life. So obviously the quantum computers in the future, obviously without the quantum computer, everything is like incomplete. So entire world is mainly focused on the working on the quantum computing, how it help with the climate change, how it help with the fintech technology. So obviously QRACE is also doing the same thing. So the mission of the QRACE is the focusing the bridging. We are trying to eliminate the gap between the technology and societal application. And our main already I discussed with the main focus area is concerning the national priority of the fundamental science, that is a traditional science, to improve how to emerge with the technology, emerging technology, and to improve the human and the scientific infrastructure resources. So everyone is to build a business model of the quantum technology, but we are not right now. We are not describing how actually the connect with the business model of the quantum technology, because this is a separate topics and separate. But definitely, it will change the entire paradigm of the computation and the other area. So the vision is like as I told that we are working on the disruptive technology in the presence of entire environmental disruptions activities. So how actually we can eliminate the environmental disruptions? This is the basically the vision what exactly we are planning today. So our main objectives is the first is access the organizational research and environment. we are actually providing the accessing, the easy accessing to how to research with, create the research environment for everyone, to develop a process for tracking the current research involvement and decided whether to participate the future research. This is the second objective of the QRACE. Third is to develop the research training education opportunity for internal staffs and partner organization also, plan and deliver the training, workshop, seminar, research, and case study. So this is the basic actually the what exactly we are planning to do, and the connect with the either the schools or colleges or any of the like a company, if any industry or also independent industry are connected with the QRACE, and the QRACE will trying to build the incubation center based on the quantum technology, and also to engage the research and practical realization of the quantum gates in the laboratory or in the laboratory of the QRACE. So the last is like not list, but develop the research agenda for the both organization or the eventually whatever the whoever the connected with the QRACE. Our main idea is to main agenda is to develop a mutual benefit, to develop a strong connectivity, a strong connection. As a quantum terminology, we can actually trying to create an entangled environment. So our responsibility for to how to improve the education system. The first is prospect of the quantum computing has a thrown the decks of the card available the manufacturing into the air, and creating the thinkers are exploring the new opportunity, whatever the inner mind in you are, whatever the age of the thinkers, we are also promoting that. Develop the guidance and criteria of the involvement of the future research also. We are also trying to create and guidelines for future activities for in everywhere, either the schools level or um, college level. And this is the basically the what exactly, and the last is the training and internship provided the QRACE as per the requirement of the time to time. So basic introductions. The evolution of the quantum computers or computers followed the evolution of the society during 20th and 20th century. This is the not the first time actually the entire world is actually doing. They are the part of our daily life, and with more and more computer being used in the world right now. And this access to increasingly modern and high processing power computers has brought many benefits to mankind in general, because it gives us the solution on issues that for a long time were impossible, which are directly related to our daily lives in health, safety, education, and many more others. So fabric for innovation technology, there is a four pillars what exactly we are trying to create with the innovations model. One is the strategy, second is execution, third is the tools, and fourth is the MRI. What exactly MRI is? The matrix, indicator, and result. So innovation is a critical factor for the generation of a new opportunity and a new source of organization growth for in education system. So first, what exactly what is the strategic pillar? The strategic pillar has to do with generating a more value in the interface between the technology and business model. Here we are. Why we are talking about the business model? Business model is like if any company or any organization or any education system are actually starting this, some innovations like emerging technology like quantum computing, AI, blockchains, anyone thing. So this is the first we have to understand how to interface between the technology and the connecting partners. We must remember that an organization or any sector does not aim to provide a goods, but to also to solve the problem that often the resolve the innovation and strategy. First, you have to understand what is the problem behind any of the emerging technology. So this is the main, the first strategic plan. So quantum computing comes with the with the proposal because we believe in the future in quantum technology, and we will not stop. We'll go the deeper until we reach our goal. Second is execution. So how actually, if our strategic plan is okay with that, now the execution pillar has to do with the promoting, enable the conditions for the creation of the knowledge and innovations. So second thing is obviously we have to create a knowledge and innovation. The combination, the entangled with these two things. First, the basic understanding why the quantum computing is more important for the for educational system, and second is what type of innovation is basically we are planning to do in the particular in quantum computing. So in an organization, it is possible to identify the people who, regardless of their positions, have leadership, confidence, risk taking, and more exploitative, and so on the profiles. So basically, the here the first we have to identify the who are the basically the main people are to doing the quantum computing particularly, or any of the emerging technology like that, AI or blockchains or nanotechnology and something like. Now second thing is to develop the skill like in particular for the emerging technology, or the student, if we are also trying to identify those students who are more prone to the concern about the innovations like that. So that's why the Niti Aayog actually already started that beautiful mission. That name is the Atal Innovation Mission. Under right now 5,000 mentor of change are connected with the Niti Aayog, and they are basically it's a very short, it's a very small number, but the planning is already going on. And the Niti Aayog, one of the basically the organization, they started the some innovation idea with the Atal Innovation Mission, and these schools are basically the creating that the Atal Thinking Lab, and the students that are connected with the Atal Thinking Lab and mentor of change, basically the leader, what exactly they are providing, they are actually the supporting, and they are actually sharing the knowledge or innovation with the schools students or teachers also. So knowing how to harness the skill to explore creating is to use creative trust to generate innovations and knowledge. Now, last is the tools and metrics and indicators, results, what exactly the MRI. The pillar have to do with choosing the most appropriate resources, techniques, methodology, and that help the promote and measure the innovation in any organization. So first, obviously we have to strategize. Second is obviously identify the people who actually connected with the that emerging technology. Now the third thing is to appropriate resources. So where is actually the quantum computing resources is available? Is there any organization or any software tools or what exactly? And which techniques are actually we are actually trying to pursue these technology, and which methodology is more important for the develop the quantum computers, or what exactly, and how to pursue this technology with that methodology. So these are basically the basic tools to help the promote and raising the innovations. So the behavior of those involved in the teams can be identified through the games or dynamic, and tools can be fantastic if they are in the right hand. So quantum computing, it's like a life. It's not like a like it is a real what exactly. So we can plan a something like we can create a game, and we are enjoying this game with through the technology. Like obviously the quantum is like a simple, it's a zero one in digitally we know that in classically. So every information is connected with the two levels, either one and then zero, either like a hardness or either softness. So simple, there is a two levels. Here the quantum computing, again there is a two levels, but it has a superposition. And how it is superposition, I will explain later on. So the my motivation why I started this journey is in quantum in particularly, and it start that my journey as a, and definitely it's a part of my life. So quantum is what, quantum is the physics or it's the mathematics. Everybody is like talking about it is a part of the physics or it is a part of mathematics, but my perception is little bit different from the others. Is also obviously it's I did my engineering and completely in the BTech, MTech, and PhD, and some engineers views is always different from the any of the physics and mathematics. I mean, it is not a different, it is always we combine with, but definitely something is different from the others. What exactly the quantum mechanics or quantum is the mathematical framework. It's like a frame structure of the mathematics to construct of the physical theory, and that definition is actually described by the Feynman, a famous researcher novelist, the Richard Feynman. So the physical theory is popularly known as the quantum electrodynamics, and it provides the accurate and precise descriptions for many phenomena, and that these classical theory simple cannot explain as the atomic and subatomic level. Now we are talking about what exactly the quantum. So obviously, if you use the quantum technology, we are not talking about the some mega or something like. We are talking about the like a nano in order atomic scale, and that the classical theory is not valid for that level. So quantum revolution is not new. As I told that from the beginning of the 20th century, the numerous groundbreaking technology already, like transistors, laser among them, and have had the quantum physics at already there in origin. So quantum mechanics is the fundamental branch of theoretical physics. It's a branch of the theoretical physics with wide application of experimental physics and replace the classical mechanics and classical electromagnetic at the atomic and subatomic level. First, there the eigenvalues are always real. The first you have to know some basic things what exactly I'm trying to explain. In quantum mechanics or a quantum computing, this is eigenvalues are always real, and this is the important because their eigenvalues corresponding to the physical theory of the system, which cannot be imaginary or complex. Obviously, how to connect with this technology? The basic understanding of the mathematics, simple. So everybody has like knows or during the 10th or 10 plus 2, they studied already the eigenvalues, eigenvectors, some complex analysis, some linear algebra basic things. Even these basics is also very is the sufficient for the understanding of the quantum computing. And second, the eigenfunctions or what eigenstate are the orthogonal, and which greatly simplify with many quantum mechanical problems. Now, here are the two basic things what exactly I'm trying to explain. The first is superposition and second is entanglement. So entanglement is right now is like if the two systems are entangled, that means at the same time they are working like they are working with the library. This is like if and the quantum system is basically work on the half spin, like electrons are like at the same time they are act as a like zeros and one, and the information is traveling without any delay. So the a unique quantum physics property that allows the two and more particles to act the correlate way even when they are space. So the quantum correlation cannot be explained in classical terms, like a Bell theorem already explained about that, but the quantum correlation is not actually the explain. So a quantum entangled quantum system should be thought of the one coherent whole, even if it contains a many particles. So in describe the quantum is in described in the state. So entire quantum wave functions is basically in the form of this quantum state, and that quantum state described the Glover, which first time they introduced the coherent state. Coherent means it is actually the phase and frequency are entangled with the everywhere in the transmitter side and as well as the receiver side also. For entangled system, the whole is more than the sum of its part in well-defined physical and mathematical terms. Now, second, as I told that the second is a superposition. So basic understanding of the quantum system, first you have to understand the entanglement, what is the entanglement, and second is the superposition of the state. Superposition means a system can be in the two or more of the states simultaneously. If two systems are superposition, that means that at the same time, every state are actually aligned with the single thing. So for example, the single particles can be the traveling along the two different paths at once. So this is the basic, actually the diagram, what exactly I'm trying to show here. So this implies that the particle has wave-like functions. So as I told that the quantum is a mathematical framework and which described by wave functions, okay? And that wave functions is basically described by the first time the scientist's name is Schrodinger. So Schrodinger is already first they introduced the actually they described the quantum mechanics as the wave functions. So quantum mechanics is like a wave function. It's a wave is like a sinusoidal function. Sinusoidal, it's a complex conjugate. So like a sine and cos is the combination of, and which can mean that the wave from the different paths can interface with each other. So our objective is to here we are actually why this slide is important. As I told that the QRACE is basically and our my objective is also to design a quantum computers and to preserve the unitarity of the what exactly I'm what exactly I'm trying to describe here is, and with the excitation of atom and molecules of the electromagnetic wave, because without electromagnetic we cannot describe the quantum gate design or quantum computer, because the ions and molecules are basically excited from that either electric field or the magnetic field. So a particular situation of this involves the ion trap experiment in which the quantum electromagnetic field interacting with the ion model as a three-dimensional harmonic oscillator. So what is the quantum computer? So a quantum computer is a machine that performs a calculation based on the law of quantum mechanics, which is behave of the particle in subatomic level. So the basic understanding of the quantum computer is the Moore's law, and which hit the quantum level of the 2010 to 2010. Now it will completely change exactly There is no any such type of the moves are already in classical theorem. Now it, but they did not describe at the atomic scale. Now, how it is exactly represented? As the figure shows that in a classical bit, always the we can transmit this either 0 and 1. We cannot transmit the simultaneously all the information at the same time. But in quantum computing, we can transmit the all the information simultaneously because it is a combination of superposition. It's a combination of 0 and 1. So that's why in quantum computing or quantum computer they use the qubit, and in classical computer they use the bit like either zeros and one. But in quantum computer we can use the qubit is could be both or one and zeros at the same time. At the same time, that word is at the same time, it is like an entanglement. If we and r both are entangled, that means we can transmit the information or zero and all the information at the same time. We can transmit through one position to another position. So with three qubits of data, a quantum computer could store all the 8 combinations, because 2 to the power n is the actual the mathematical what exactly I'm showing here. So 2 to the power n possible permutations is actually showing. So if you have a 3 qubits, so that is how many combination? That is a 2 to the power 3 is 8 combination. So a bit of the data is represented by a single atom that is in one of the two state, denotes 0 and 1, or that is a cat 0 and cat 1. So single bits is form of the known as the qubits. So what is the qubits is what exactly is I describe here. Now I am just trying to basic actually the information and how actually the actually correlate with these things, and how it helps to anyone to understanding the quantum computing, to connect with the exactly to research or how it helps. So first we have to understand for the basic terminology and notation of the qubits. What is the basically notation of the qubit? It is a linear combination of superpositions. Is basically uh, describing it is a linear and homogeneous. Superposition means that is so it is definitely it is a linear combination of 1 and 0, and it will help though everyone like understanding of the like school level or college level of the any of the understand. So students need to understand the qubits first. Second is, and it is a 1 and 0 space of the B, and first second is and understanding of the what is the state space of the state vectors and understanding the these things. Third is the qubit may be used as a placeholder. So third, we how to write a combination, how to write a basic equation of the quantum computing, quantum wave functions, and in the form of zeros and one. Fourth, the obviously it is notation of the tensor product. So this is the basic understanding, as I told that the linear algebra, if you understand the linear algebra, if you start the linear the basic things, now you can connect with these things. So this is the basically the process to connect with anyone, like either they are the background of the research background, or they don't have a research background, they can connect with these things. Now next is understanding of. So in qubits has a two possible. As I told that the information has only two possible, either zeros and one. Here is also two possible, but the notation is basically the cat 0 and cat 1. So unlikely that description of the qubit is a superposition is the cat psi is equal to alpha cat 0 plus beta cat 1. So these basic understanding, without understanding of these things, we cannot pursue the quantum computing in anywhere. So understanding of the quantum computing, we have to understand the basic notations of and terminology of the quantum computing, and then understand what is the superposition, or what is the basically entanglement. And so start from the anyone to connect with the vector space of the two dimensional, and as I told, the 0 and 1 are the orthogonal because both are in complex conjugates. So it's orthogonal computation of them. And this is the matrix notation. So sometimes it is also quantum mechanics is called as quantum matrix mechanism also, because entire quantum is form of the matrix mechanism. As so in 2000 like something as 10 years before or something, one of the movie came from the matrix, and that time nobody actually the understanding of the how it looks like and why exactly it's going on these movies. So my personal suggestion is to connect with some basic things with the games, movie, and something like that. Entire quantum computing is like a matrix mechanism, and representation of the matrix mechanism is like a 0 and 1 in the form of like this. So this is the basic wave functions representation of the quantum state, how it looks like that. I have mentioned that putting the quantum state in the form of superposition. And the most important thing is the A and B for the newest existing of the unitary state, it must be unitary. That means the probability of the A is square plus B square mod k square is equal to 1. So the most important thing is the entire quantum wave functions or state is a unitarity. So it validates for the unitarity, then it will work. And so that's why it is working as a, like some technique is like a unitary evolution technique. So why it is a unitary evolution? Because the mod of a square plus mod of b square is 1. So like if one why I am talking about the quantum computers or quantum state, why like gates or quantum computers working on the unitary evolution technique. So if you will give any information through that through gate or through that system, it definitely you will achieve the same information from the receiver side. So quantum state is the one is the phase is difference. If the state is one phase is like a psi one, the another state is the phase e to the power I gamma. So the phase is only difference. The but magnitude side is always the same. This is the basic understanding of the. So all quantum operations have to be reversible. The Boolean operations are not necessary to it will be the reversible or irreversible, but all quantum states are reversible. So reversible operations always given as the unitary matrix. So this is the beauty of the quantum computing or quantum mechanism to give the unitary matrix, and it follows the unitary unitarity techniques. So this is the basic understanding of the what exactly I'm trying to show you. So this is it will show the unitary u dagger. This is the notations. So this is so now the conclusion is so the understanding of the education and it will help the it will help a lot for the education if you anyone starts pursuing with the innovation with the like such emerging technology. So the first you understand the how it will help and how it will connect with the so the concluding part of that we have to understand the first things the basic the basic mathematics, not the so much hypothetical things what exactly maximum scientists and researchers are doing that. So understanding the what is exactly the quantum computing, how it is represented the qubits as instead of the bit. The classical bit information is a bit, and definitely the quantum mechanism or quantum computing is represented as a qubit. Third point is like understanding the superposition. Why the two methodology is more important in the quantum computing, the superposition as well as the entanglement. Now we can understand the which physical implementation of the qubits using either ion trap, Rydberg atom, hydrogen atom, any of the system we can. But the basic system is a harmonic oscillator. So understanding of these things, after that we can start or pursue for to understanding of the system for limiting by the interacting of the qubits and their the environments and resulting decoherence or coherence, something like that. Now, quantum technology promises to deliver the considerable growth and progress in speed of data. Now, why? What is the benefit of that? Obviously, the quantum computers is not like you have any hand like any of the computers, not like that. It is important for the speed of the data treatment of certain complex and operations as well as the anticipating or the simulating the certain and natural process. So these interaction of the qubits set the maximum time of the coherent operation and upper bound for the number of quantum gates operation to be applied on the single qubits. So therefore, the understanding the origin decoherence to create critical to control and reduce it in order to implement the quantum computer. So this is the basic exactly what I did during the PhD, and right now I am also trying to pursue the designing of the control gates or quantum computers is the basic understanding of the quantum Fourier transformer. So many actually the gates are actually there, and they can pursue any of the quantum system. They can start like a hydrogen atom or ion trap or Rydberg atom. So for business purpose, the India and other country offer an opportunity to meet with the future user, and obviously the government of India, even Prime Minister, Honorable Prime Minister Modi ji, they have huge, they have another vision about the like they are already connected with the young mind, And that young mind is not only connected with the, like, a young mind is not defined for the only the students or below the age of the 18 or something. Like young mind is connected with the any of the age, like they are also young with the young mind if they are connected with the emerging technology, whether they have an age of the 80 or whether they have an age of 40. Comes and last, obviously, the quantum computing solutions and services in front of the captive business audience and the future bright for the new and innovation technology. So everyone, and say it's welcome to everyone to connect with the and if you have any questions and doubt regarding that, how to start the pursue and how it helps. But definitely the traditional education is already definitely this is very important for traditional, but basic understanding of the traditional education is more important to connect with the emerging technology like quantum computing, AI, and other. So these are resources we can go and connect with that. So the basic is like to promoting the education, so promoting the innovations and innovative ideas. The government of India started the Startup India research grant for any of the person. They have no any age bar or any age bar or some group, like they will not provide some like only researcher. Anybody can join Startup India emissions and apply for the grants, and they will give if you have if you are connected with the innovations or something like that. Second is the core research grant. This is basically the schools, college level. The any professors or any of the scientists can apply for this grant for a special call for the proposal. NITI Aayog, the beautiful like aim is like NITI Aayog started the aim challenges. Obviously, every year they are started the new challenge missions in so many technologies. Right now, basically, the NITI are more prone to concern about the mobility, the electric vehicle also. Quantum computing is not right now, they are not touching, but obviously they are planning to create already. They are connected with the artificial intelligence and blockchain, fintech, nanotechnology. So that is already included. DST has already started the quantum missions, Quest, the quantum information science and technology. Nidhi Prayas, this is a small, basically the one of the DST based incubators. They are providing the 10 lakh grants for the uh, um, any of the incubatees or any of the researcher or entrepreneur. They can enjoy. They can apply for this grant, and they will get through that DST. Second is there is also the Supra and Basic. These are some international organizations into Indianis, and they are also providing the resources. So these are resources. This is not very limited resources. What exactly I'm providing here. But other than that, you can connect with the QRACE, and I will also give a more informations and opportunity to everyone to connect with that. We can also plan to workshop and training program for that developing of the quantum, how to pursue the quantum computing and how to improve the educational system in particular emerging technology. So these are basically sector and subsector where they are planning to. If anybody are interested, these are basically to area where to connect with the quantum computing through the quantum, like a quantum computations, computing the any of the systems. Communication DRDO right now working on the. If you have any idea in the quantum communication based, that you can apply or connect with the DRDO, and they will give quantum simulator and sensors. The ISRO are basically working on that. They are also planning to build a quantum sensor and so on. And these are my partners right now, and associated with these partners and signed with the MOU. And this, thank you so much.
Thank you so much, sir. You made very, very valid points, as you focused upon the mission, the focus, the business model of quantum technologies, objectives of your organization, responsibilities in developing the guidelines, strategic innovation model, which consists of four pillars, which I could get, like strategy, execution, tools, metrics. You made very valid points, which is very, very relatable in the present times. And we believe that machine learning will definitely ignite with the capabilities of quantum computing. And just
Yes.
as quantum computing is expected to revolutionize the medical triage and diagnosis in education, quantum driven algorithms will also make informed decisions on our student learning and deficits. We don't even know that by what means entanglement communicates. So at this time, it is perfectly secure and it is perfectly fast also. Faster than the speed of light, and who knows that better than you? These values of quantum computing definitely are the key factors in achieving the penultimate goal in education of a truly personalized learning. There is a lot on the horizon in this field, sir. So, what should we actually do today? I would like to put up a few questions to you and would be glad our viewers too would be very happy if you take our questions. My first question to you, sir, is in what ways would quantum computing affect our education system?
Uh, Quantum computing, basically, the first you have to understand the basic mathematics and physics. First, understanding that, because many people are basically confused to how to start and how to pursue the way to create the innovations, or any of, is the possible to design a really the quantum computer? Yeah, definitely we can design and we can pursue that way. But understanding of the basic things, what exactly I already discussed about during the presentations, the way is understanding how actually the zero and ones, what is the two levels, why? Because the electrons has the two characters, either love and hate. Things that's simple. So the connect with the quantum computing to understanding the basic things, to connect with the real life, like the people are sometimes sad and sometimes happy, that is also behavior of the quantum mechanics. Okay, so now it is a combination, because the one person has the two character, like one is sometimes they are behavior as zeros, and sometimes their behavior of the low is the ones, are like one and zeros. So this is the way, the first, to understanding the quantum computing, and then start the develop of the quantum and to build the education system. So we have to incorporate these things in the basic thing.
Thank you so much, sir. The big changes in the world that are taking place, how do you think it will further also bring about revolutionizing changes with the emerging technologies?
Obviously it will change completely revolution. Why? Because it will help you every sectors, health sectors, climate change, and everyone. And right now the entire world is basically doing on that particular area. So quantum computing is obviously understanding of the things is, it's very difficult, very less. I mean, 5% of people are basically working on this. The huge like opportunity to connect with that world, but understanding is that to how actually it will be completely changed. That obviously first you have to choose and characterize where we can pursue for that emerging technology. So it will change and it will completely vanish whatever the problems is there in the in the real world. It will sometimes be hypothetical, but it's not, it will be hypothetical. Understanding of the quantum computing, it will change the completely paradigms.
Thank you so much, sir. One last question, that how would the quantum computing affect the future of computing itself?
As I already told that, the obviously right now the if you talk about the health sector, we need a faster data calculations. As you told that the ML is the best algorithm to develop in health sector. And right now the quantum machine learning is already working on the some of the institution and in IITs, and even IIT Indore, one of the professor is working on the health sector, and they are developing the some device for the for it will. So obviously because we need a faster calculations, if we have a huge data, and the data is like the calculation is some atomic scale, as the something like that, the fraction of second we will achieve the solution. Definitely we can change the entire things, and it will help the everyone, like it will change the basics, like it will improve the lifestyle also, and for improving these things.
So, what according to you do you think are the basic differences between quantum and classical computers? Quantum and classical computers.
Yeah, basic difference is simple. In classical computer, they are working on the one level, two levels. Like either they are working on the zeros and ones. Okay, but they have some limitation. If you talk about the some atomic scale, like a nano to atomic, then the classical system are not working properly. Okay, as I already discussed with the quantum in during the PPT, the classical computer has just some limitation. They cannot calculate faster. They cannot actually the calculate the complex data with analysis. So this is the basic the real advantage of the quantum computer. They calculate all the information because it is a combination of the superposition. It is a linear combination of zeros and ones. So there is a no separately. Suppose me or you are actually entangled each other. The, all information are connected at the same time. All the information are traveling and the one position to another position. There has no any time gap or no time delay. So this is the beauty, and we can calculate faster as compared to the classical computers. So obviously, the quantum computer work on the qubits, the basic understanding, but in classical computer, the work either 0 and 1, not it's a combination of 1 and 0.
Thank you, sir. You explained everything very clearly, and I think our viewers, their doubts must have cleared and they must have got a deeper insight into the entire quantum computing and how it's affecting our education system. And you also focused upon the two principles of quantum mechanics crucial for their operation, and that is superposition and entanglement. So I think you covered the entire topic very beautifully, and even even a person who is in the mid of things would be able to take and have a proper graph of the idea of what it actually is like and how it's going to also affect the education system on the whole. So, with
Yeah.
this, I sign off, but not without quoting that innovation is a critical factor for the generation of new opportunities and new sources of organizational growth. Knowing how to harness the skills to explore creativity is to use creative trust to generate innovation and knowledge. That was the main input that I could take from your presentation. So I thought it would
Thank you
be
so much.
the best to end it that way. And thank you so much for sharing this evening with us and with your very
Thank you.
relatable, very relevant, and valid inputs. Thank you so much. Thank you, dear viewers, for being there with us and for gathering enough points about what all went well with this live session. Thank you so much, sir. Thank you, dear
Okay.
viewers.
Thank you, ma'am.
Stay
Thank you
blessed.
so much.